Now let's start with the next topic, that is load sharing by parallel units. This is one of the important topics in LFC, load frequency control. Let take two generators having the different dropping characteristics which are connected to the power system. We can take more than two alternators also, but in this example I am assuming the two alternators, and let us assume that there will be a unique frequency at which they are capable to share the load. Fine. Now let the two generators having the dropping characteristics are shown in the figure below. This is the diagram. Fine. And let the initial frequency of both the alternators are shown by f dash. This is the dropping characteristics versus frequency versus the output power. The left hand side is for the generator for the unit 1, where the load is changed from P1 to P1 dash, that is the change in the output power delta P1, and correspondingly there will be the reduction in the frequency from F dash to F double dash, that is the change in the frequency delta F. Similarly, on the right hand side we can see that when the load is increased from P2 to P2 dash, there will be a change in the power denoted by delta P2, and correspondingly the frequency will get reduced from F dash to F double dash. Here we have to remember that as the load is increased, the frequency is getting changed, because we are not assuming any load frequency control mechanism here. Fine. So as the load increases, it will cause the units to slow down, and the governor increases the output until they reach a common operating frequency F double dash. So in the last lecture we have read about the speed governor speed regulation parameter, that is R, and R is the ratio of change in the frequency with respect to the change in the power. Fine. So I have rearranged it. So from that formula we can write it as delta P1 is equal to delta F upon R1. R1 is the speed regulation parameter for unit number 1, and delta P2 is equal to delta F upon R2. R2 is the speed regulation parameter for the generator number 2. Since the change in the frequency is same for both the generators which are connected in parallel, so from these two equations we can conclude that delta P1 upon delta P2 is equal to R2 upon R1. From this formula we can see that change in the power is inversely proportional to the speed regulation parameter. Now take an example. Two similar 4000 kilowatt alternators are operate in parallel. The governor of first machine is such that the frequency drops from 50 Hz to no load to 47.5 Hz on full load condition. The corresponding drop of the second machine is from 50 Hz to 48 Hz. Now we have to find out how the load of 600 kilowatt will be shared by both the alternators, and at that time what should be the system frequency. So in this question it is given that the change in frequencies are given from no load to the full load condition, that is delta F. No load to the full load condition for both the alternators are given. For alternator 1 it is 50 Hz to 47.5 Hz, that is the change in frequency is given, and for the alternator 2 50 Hz to 48 Hz frequency drop is given. This is for the alternator 2. Fine. The total load now the alternators have to share is 6000 kW. Let we assume that the load shared by the generator 1 is x kW, while the load shared by the generator 2 will be, obviously it will be 6000 minus x kW. Now for the generator 1, when full load is shared up to its rated capacity, that is up to 4000 kW, at that time speed regulation parameter R1 is equal to delta F upon delta P1. Always remember, delta F is change in frequency from no load to the full load condition. Fine. It is given 50 minus 47.5 divided by P1, change in the load. Change in the load, it was from no load to the full load. Full load means up to its rated capacity, that is 4000. So it is to be calculated, it is equal to 2.5 upon 4000 Hertz per kW. This is say equation number 1. Similarly for the generator 2, when the load share is up to its rated capacity. So R2 is equal to delta F upon delta P2 is equal to 50 minus 48 upon 4000, that is 2 upon 4000 Hertz per kW. Now for sharing 6000, it is kilowatt, it's misprinting, slightly misprinting is there, just take it as 6000 kilowatt. Let the load shared by the generator 1 is X kW, fine. Therefore R1 is equal to delta F upon delta P1. Now what we have to calculate? We have to calculate the speed regulation parameter when the load sharing is X. So it can be written as delta F upon X Hertz per kilowatt. Please do remember, we don't know what is the change in frequency when alternator 1 will share the load of X kW. So delta F is not given here, just keep the equation as 3. But R1 is constant for the generator for each and every loading condition as we have discussed. So equation 3 must be equal to the equation number 1, that is delta F upon X is equal to 2.5 upon 4000. From here delta F is equal to 2.5x upon 4000. Similarly, for sharing the 6000 kilowatt, it's again a misprinting, it will be kilowatt. Let load share by generator 2 is 6000 minus X kilowatt. Therefore R2 can again be written as change in frequency upon delta P2. What is the change in load here? 6000 minus X, but we are still unaware what will be the change in the frequency, so I just keep it as delta F. But for each and every machine, speed regulation parameter is constant for every load condition. So equation number 5 will again be same as the equation number 2. From here we can write it as delta F upon 6000 minus X is equal to 2 upon 4000. That is delta F is equal to 2 upon 4000 in the bracket 6000 minus X. Fine. The main thing we have to note here is delta F is same for the alternators who are connected in parallel to share a common load. So by equating the value of delta F of equations 4 and 6, we will get 2.5x upon 4000 is equal to 2 upon 4000 of 6000 minus X. From here we will able to find out the value of X. What is X? X is the load shared by the generator 1. So the load shared by the generator 2 will be 6000 minus X, that is 6000 minus 266.67. It is equal to 3333.33 kW. Now the system frequency at this moment at the load of 6000 will be, we have to find out the system frequency. So system frequency is the new frequency. We have already read that the change in the frequency is equal to frequency at no load minus the frequency at a particular load condition. So system frequency at a particular load condition is equal to 50 minus delta F. Now we are aware of the value of delta F. So delta F is equal to 2.5 x upon 4000. You can write it from the equation number 4, or you can use the equation number 6, that is 2 upon 4000 of 6000 minus x. Fine. So from here delta F can easily be calculated. So it comes out to be 48.33 Hertz. At this frequency, both alternator will share the load of 6000 kW.